All right, so Webpack. What is it good for? What is it? So Webpack is known as a bundler. There we go. So a bundler is necessary nowadays when we're using frameworks. Because can the browser read React code or Angular code or Vue code or Sass or any of those things? Any of those, like when we say require and we're linked to an HTML page, what happens? Do you remember when if like we had an app.js page and we said require, some other file, and this was linked to an HTML page, do you remember what happens? The HTML will immediately say it does not know what require is when we say go live and try to load this in the browser. Because that is a node keyword. It's something that the HTML page or the engine that runs JavaScript in the browser has no idea what that means. So in order for us to be able to write in React or these other frameworks and use these interesting syntaxes to interact with the DOM, we need something to take all of our fancy code and bundle it down into what the browser can read, which is mainly a .js file, a .html file, a .css file, and then static assets like JPEG or PNG. We need everything to come out at the end of their line like this, and it needs to be all regular code the browser can read. And Webpack is the most popular bundler for React applications. There are other bundlers. You may have heard of Grunt or Gulp. They have similar attributes. They look a lot different than Webpack, but they aim to achieve the same effect. But here's a visualization from it from Webpack's homepage. Here's all your files, your modules with dependencies and Node. It runs through the Webpack process and outputs static assets that the browser can read. So every time you say npm start and create React app, Webpack is actually running its bundler, and this is what we're actually viewing in the DOM, even though we're writing like this, bunch of files all over the place, importing, exporting, and so forth. The Webpack documentation is amazing. If you go to documentation on their site and just start at concepts and read down, this is how I learned it, was just reading their docs. I found them pretty straightforward. There was one tutorial I had to watch to see what dependencies are needed for a React application, what are the most popular or most used. So that's where we'll get some of that content, but really their documentation is awesome. So reading is good. All right, so we're gonna make our own React application here. We're not gonna rewrite React, we are gonna install that, but we're going to not use create React app. We're gonna set this all up on our own in this directory. Now there are a lot of dependencies that go into this, and we'll briefly cover all of them as we do it. But let's start off with our folder structure. What is the folder structure we get with create React app? What are the main folders we have inside of the client folder? Source and public. Cool, so we're gonna have to create those ourselves. Got it, that was pretty rough. I'm gonna add a git ignore. And I will do an npm init-y for a package JSON. Cool, I'm setting up my own project. Notice what it refers to when I npm init without a file. It automatically makes an index.js, which is a convention. That's what we put in our source folder. It's the top level of our application. This is a nice node convention. All right, so we need a couple dependencies to start off with. I'm going to npm install Webpack, which is the entire Webpack package. But in order to interact with this, we also need to install the Webpack CLI. Now, all of the dependencies I'm installing, except for React and React DOM, are only for development purposes. So we need to introduce a new flag, and that is the --save-dev flag. We haven't seen this before, so let's see what it does. So I'm going to install Webpack and Webpack CLI underneath the save dev flag. And notice what appears inside of my package.json when this gets completed. Oh, it's going to take a second here. All right, what do I have in my Webpack or in my package.json that I have not seen before? Dev dependencies. What's the difference between dev dependencies and dependencies? Dev dependencies are modules only needed for development purposes. So they won't be included in the final build. This is just so that we can get the final build to deploy to a website. So almost every dependency, we'll install about 15 or 16 of them, I think. Will all be development dependencies, then we'll install React and React DOM as regular dependencies. But those will be the only ones. So once you have Webpack and the Webpack CLI installed, you now need to make a configuration file for your Webpack.
So what if you downloaded a repository like this and had a package.json with dev dependencies listed? How would you install the dev dependencies?
I believe npm install will still
Install everything?
Yeah, you may still, I have to double check that. So to build your Webpack, there's one primary file that you need to add to your directory, and that is a webpack.config.js file, where we configure our Webpack. And this is where we type how Webpack is going to take our code and build it into a final product for the browser. Everything in this Webpack is combined with, is inside of a module.exports. So we'll say module.exports, an object, and this is where our entire configuration will live. There are two main properties at the beginning of our Webpack config, namely an entry, which is a string, and our output, which is an object that we fill in with some data. What these are for is to say, Webpack, when you start the bundling process, this is where I want you to start, and when you're done, this is where I want you to put it. Entry, what is again, the top level file of our React applications? Cool, so we'll say look in the source folder at the index.js file to start your bundling process. Output, this is not something we may have seen yet because we don't really run npm build. We kind of have the dev server do that for us, or Heroku do that for us. But we need the path module from Node to do this. I'm going to say const path equals require path. And the output, what this is going to do is say, take everything when you're done and create a directory called dist, or distribution. We'll call it dist as like a convention. And then the main file of that we're going to call main.js. That's going to be all of our JavaScript in one file. So we need to give it the path to where to put it when it's done in relation to where our configuration folder is. So we're going to say resolve the following path. If it doesn't exist, create it. That's what path.resolve does. We're going to say resolve a directory name called dist. And since I didn't say like ./public/dist, it's going to put this dist folder on the same level as all these other folders. This is what we necessarily could, put on the web. Now, what do we want the main file of that to be, our main JavaScript file to be? We have to give it a file name, and we will call it main.js. Now, with the introduction of Webpack 4, I think it was, the newest version, this is the default. So if this is what you want, you actually don't have to even put it in your Webpack. But that's how the initial setup works. Any questions on entry and output? It's all conceptual right now because we won't see it till it's done, but no questions.
We don't have to add it, it'll still run the same way, you're saying, as with Webpack 4?
Yes, as a Webpack 4, this will be the default. So you'd only really write this unless you want to change it or you just want to make sure it's there. I always write it just so I know it's there and I can change it if I want to.
So where is path coming from? It's like a default dependency, or what is it?
Yeah, so Node comes with a bunch of dependencies that we don't have to install. They are part of Node, and path is one of those. It's a utility tool for handling paths, which is like / a file name, creating paths to files or folders. Path.resolve, when we use __ dir name, we're saying resolve this path if it doesn't exist, which means create a directory called dist at that level in conjunction to where my configuration file is. So it's going to make a literal dist folder like this when I run the Webpack process. And that's what the output needs. It says, where should I put it and what should I call it? Okay.
Is that what happens when we run? Do we have a distribution folder in React apps?
Only if we run npm build, which we don't, because we have Heroku do that for us. So I'm going to keep a track of all the dependencies we have. So far we have Webpack and Webpack CLI, the ones that we have to install manually. Now the write-up I have on this lists them all out for you, so you don't have to memorize this or take notes as this is all written out. Where did it go? Okay, so Webpack comes with a dev server. When we say npm start, it runs a quick build so we can see our process. Now that we've installed Webpack, we need to tell it what to do when we npm start. We want it to run the Webpack dev server, which is a property of this dependency. So we need to go to our package.json and configure that next. We need to add the script that we use for starting up our application. What is the one that we've been using? npm start. So we're going to say there's an npm start script for this application, and what it's going to run is the Webpack dev server. Keep it open. So the hot reload, you make a change in your file, Webpack automatically recompiles and you see the changes. And the mode that this is running in is the development environment. So that will make it so we can say npm start. Now, if we want to create our distribution folder and have it ready to deploy on the web, we can have a build command, which Create React App comes with as well. And we need to tell this to use Webpack in the mode of production. So when we say build, we want to use Webpack to build our production app out of all the code, starting with the index.js. So these are the two main scripts we need to tell it for our package.json. All right, so the rest of the package, or the rest of the webpack.config file is telling our Webpack a lot of the time how to handle certain files, or a big portion of this is. So when you run into a JavaScript file or a CSS file or HTML file, what should you use to bundle it? Does anyone remember or know the main utility software used to take like ES6 or ES7 syntax in JavaScript and convert it back to the browser? There's a certain package out there that's used the most. Babel, I heard it somewhere, Babel. So we're going to tell Webpack to use a package called Babel whenever it hits a JavaScript file to know how to handle it. For this, we need to install another dependency, something called npm install save dev Babel loader. And loaders are how we handle file types with Webpack. When you hit a JavaScript file, we're going to use the Babel loader because it knows how to handle JavaScript. When we hit CSS files, we're going to install something called the CSS loader or a style loader to handle the CSS files or the styles. So npm install Babel loader. And now we can start adding rules to our Webpack so it knows how to handle different files. This is under a segment called module. It's an object that has a .rules that is an array of rules because there's many different file types. We need many different rules to be able to handle the different file types. So the first rule we'll make is one for JavaScript files. And how you define a rule is first you give it a test key. And this says this is what defines what file type is going to get bundled by the specific loader. We have to give it a regular expression though, so if you've never seen those, let's see one now. Looks like that. Regular expressions start with a / and end with a /. The .js $ is saying test any file that ends in .js. So it's looking for a .js file. That's what the $ says. Anything in between here, it's just going to look for .js anywhere in any file. We say only look for files that end in .js. So if you find a file like that, then we want you to use the following loader, which is the loader, Babel loader. Well, where are some JavaScript files we wouldn't want to have bundled? What don't we want to push to GitHub typically? Node modules. So we can tell it on these rules to exclude certain files. We're going to tell it to exclude anything in a folder named node modules. So test the JavaScript file. As long as it's not in the node modules folder, use the Babel loader to compile it and bundle it into regular JavaScript code. And now we can handle our JavaScript files. Hey.
Do we have to require Babel loader at the top?
We don't. We're just telling it to use it. You may have questions, or you may not just know what's even going on, and maybe that's the main question, what's happening. For this module, we're going to be defining rules on how to handle each file name, and we do that by saying test for this extension and use this loader if you run into that extension. Well, Babel is a very large library. It handles all sorts of JavaScript, all sorts of packages. It can be used for Angular, Vue, React. So we need to tell this Webpack what type of JavaScript we're using by configuring our Babel loader. So we actually have to configure our Babel loader by itself because we need to tell it exactly what kind of JavaScript we're writing. For this, we get to install more node modules. We're going to npm install with the save dev flag. Let me remember the name of these. @Babel core, @Babel preset env, and @Babel preset react. So here is the core JavaScript package for Babel. I forget what the preset env is for, but this is saying that we're using React. This is, we got to spell that right or it's going to fail. Babel. Core, Babel preset env, Babel preset react. Okay, we'll install those. But we need to configure this, so we need to make a dot file for our Babel loader so we can configure it. So one more file we'll make is the .babel rc. This is the conventional file name for configuring a Babel loader. And all we need to put in here is an object. And this is a JSON object. It's a very common syntax for configuration, just like the package JSON uses JSON. Babel RC does as well. And we need to tell it what code we're giving it. And the way we do that is by giving it a presets key with an array of what presets we're going to use. Well, the two presets we installed was the @Babel preset env and the @Babel preset react. So it knows what kind of JavaScript we're writing. Babel RC Webpack config. Let's add the rest of these dependencies that we've just added to here. So we have the Babel loader, and the Babel core package, and the Babel preset environment package, and the Babel preset react. Quite a few things so far. Hopefully now you're already seeing why we jump into create React app first. And why most interviewers are like, don't configure your own environment, just come with create React app and show us how you build stuff. Right, so there is one more configuration we'll want to make to our Babel RC file, and then we'll be done with it. And it's a node module that allows us in class components to have auto binding with arrow methods. It helps condense that syntax that create React app allows us to use. And it is actually a plugin that we have to give our Babel configuration. So we'll npm install as a dev dependency at Babel. This is the longest dependency ever. It's plugin, proposal, class properties. So I don't want to write that again. I'm just going to copy it and add it to the list. So in our Babel RC file, we can add another key for plugins. With an array of plugins, we're going to say use the app Babel and just copy the name of that package.
You said it enables auto binding for the fat arrow button?
Yeah, when you're in class components. That's the main use that I've found from it so far. And I had a really fun time trying to find out what this was, because my binding wasn't working. Okay, Babel is now fully configured, and our Webpack fully knows how to bundle JavaScript files using that loader, depending on our language. So if you're building in Angular, you probably would have a Babel preset React. You'd have a preset Angular or NG or preset Vue. So it knows what kind of syntax it's about to encounter. But we have a bunch of other file types, right? It's not just JS. So we need to move down the rest of the line. And I'm going to install all these dependencies at once, and then we'll build out the rules for them. So we will npm install under the same save dev flag. And there's no way I'm memorizing this. So HTML Webpack plugin, HTML loader, CSS loader, style loader, file loader, and that should be good. There's one other one for URL loader, but we don't need it right now. So there's a whole bunch more dependencies. While there's installing, I'll go and add them to the notes. HTML pack plugin. You know, we'll go over each of these as we use them. HTML loader, CSS loader, style loader, and file loader. CSS and style loaders are for all the styling that we're using. You need an additional one if you're using something like Sass. You need to have one for .scss files. We're only going to be testing .css files. And file loaders for everything PNG, GIF, JPEG, JPG. So those files, static assets, are bundled correctly. So let's go to our Webpack file and make rules for the rest of these. First, let's handle HTML files. Let's test for files that end in .html. When we encounter one, let's use the loader, HTML loader. That does not need any configuration because HTML will not vary depending on the framework you're using. So great, we can move on to the next one. Next, we will test for any files that end in .css. And when we have that, we have two loaders we'd like it to use, style loader and the CSS loader. Lastly, we have that file loader. So we need a test for files that end in PNG, JPEG, GIF, JPG, and possibly others depending on what kind of files you're using. So we can adapt a regular expression to check for multiple extensions. We'd say check for any file that ends in dot. If we say parentheses, we can put multiple things in here. This is defining a range of values. So we'll say PNG or GIF or JPEG or JPG. And then $sign afterwards to say test anything that starts with dot, or the ending of it starts with dot, and either is .png or GIF or JPEG or JPG, and it will handle all four of these file types. If you hit any of these, we need to configure this a little bit more in depth. We're going to tell it to use which loader to use. So we're still, you can, on any of these, you can open up an object and give it more configuration. We just don't need it on HTML or JavaScript or CSS, but for files, we will need to give it some more configuration. So loader will be the file loader. And we're going to give it some options. And this is where Webpack gets confusing because it is highly customizable. So that is why I'm giving you a boilerplate setup to run a React app. So you can use it quite a few times before really trying to figure out, oh my, what's happening. So the options we need to give it is when it encounters this, we'd like all these assets to be bundled into a single folder. So all of our static assets, all of our images are in one place for our application. We're going to give it an output path, where to put it when it's done. We're going to say in a place called resources/images. So it's going to create this directory and then put a directory called images inside of it, inside of our distribution folder. And we will see all this at the end when we build our application. The other options it needs is what do you want the file to be called when it's there? Well, we want it to keep the same name. So they have this, the array syntax like we use with set state, keep the file name the same, and keep the file extension the same. So if I have a smiley.gif, it's going to be put in this directory called smiley.gif, maintaining the name, but moving it to a new path. And what's really nice is anywhere in our application where we've imported that file, it's going to be updated to this output path. So it knows where to pull it from when the build is done. Overwhelmed yet? I was. This was quite frightening when I first saw it. Because it's so new and it's so like a conceptual. You just hit a button and hope it works. And it breaks, you're like, oh my, what broke? Webpack will try to help. Yeah, Webpack, when we run npm build, we may see an error. Webpack will be like failed on loading something specific. But sometimes it's ambiguous, just like React. And not necessarily download. It's going to look through all of our files in our project and look for all of these file types to know how to bundle them using specific loaders that are built to bundle that type of file and minify it. Things like the style loader and CSS loader are really nice. They will hash your class name. So even if you have duplicate class names across multiple CSS files, they won't be duplicated at the end. So you can reuse class names in different files. This will make sure they have a specific hash on the front of them, specific ID, that makes them not repetitive or override each other. Now we will have a basic HTML file, but we need to tell it to generate an HTML file when it's done that's plugged in with the rest of our application. And the way that we do that is through the HTML Webpack plugin we installed. And that is one we actually need to require. So I'm going to require HTML Webpack plugin. But it is not part of the rules. It's after this whole, this is just for bundling files. Now we're going to give it a plugin to be able to make its own HTML file when it needs to, when the bundling is all done. So we're going to start with some plugins now. And I think this is the only plugin we're going to use. Yeah, the HTML Webpack plugin. Array of plugins, we're going to say the first one, or the only one we're using in this case, is a new HTML Webpack plugin with the following configuration. Where do you want me to create this template from? You need to give me an HTML file to start with, and I will give it a final output, just like we gave what JS file to start with and what to call it when it's done. We need to do that with our HTML file as well. So the template you're going to use is the one in our public index.html, just like we see with Create React App. When the bundling is done, create a file name, just called index.html. So we need to go create this template and make sure it's ready to go. File name. Good catch. I don't want to fix errors on this. It would be long-winded. All right, so we need to create this template. Now, how does React work? When our public folder in our React has an index.html, it is just a basic boilerplate markup like this, but what is the one element inside of the body?
a div.
A div. This is where our entire app is told to go. And what is the ID? Root. That is why on our index.h or index.js file, we say react dom.render to document.getElementById root. It's saying render my entire app. Uh-oh, don't do it. Render my entire app right here, but obviously once it's all been bundled. So here's the template it's going to use to pull from, and it's going to output the final index.html file along with the main.js file and plug them both together. Okay. Now we can test it.
In that .rc file, you didn't have sent to the HTML Webpack plugin?
Nope, this is just for configuring Babel, which is only used for reading JavaScript. Preset React teaches Babel how to read JSX. So that's why nothing HTML-wise needs to be configured with our JavaScript. This is handling that. This is purely for taking our original HTML file and creating the finalized version that's connected to our minified, bundled JavaScript and CSS and all that. It's the scary part, though. We get to test it. So in order to test it, we need to start building our React app. So we'll do our index.js. We'll import React from React and just start writing like we normally do. It's crazy that we can say document.getElementById when our index.html file has no idea about a JavaScript file. That's the build's purpose. We're going to say npm start in a few minutes and get these plugged in through Webpack. So make an app.js that's just a functional component. Default app. Now I've failed to install two really important dependencies. Can anyone spot what I don't have in here? Do I have dependencies right now? What do I need to install to be able to write React? Cool, npm install React, and what else? Close, not React Router DOM. React DOM, right? And we know this because in the index file, this is where we're importing both packages. They're two separate. So these are not dev dependencies. I'm just going to install them as is. And notice how quickly it installs. React and React DOM are fairly small packages by themselves. Now we have dev dependencies, everything just to get our app working, and then our dependencies. This is what Create React App is doing, this plus like 100 different things. It's also installing and configuring Jest and SCSS and modular CSS and all these different fancy tools. You wouldn't want to download any that you're not using, but yeah, you can download as many as you want. This is extra code if you're not using it though. Let's test it. Yeah? Yeah. Watch what happens. I'm going to do an npm start just to see if we can get our dev server working. Oh goodness. Did I not install? Oh, I completely missed one installation. I said dev server was a part of it. It's not. -- save dev webpack dev server. We have to install that separately. That's that thing that we added to the package JSON when we say npm start, use the webpack dev server, keep it open in the development mode. Now we can say npm start. It's going to run the webpack dev server. My window pops up and it says, please work. And it's the same as it always has been. I can, hello. Make it a little bit fancier just to. Just to make sure that Webpack is doing all that we need it to, I'm going to give it a little bit heftier of a test here. We're going to say this should display this .state.count. And have a button. And I'm just going to do the set state inline here. Notice what Webpack is doing down here in the console. Hot reloading is the term that's referred to that. Every time I type, it rebuilds. Oop, failed to compile this time. Nope, now it's fine. It's thinking about, oh no, it has failed. It needs something in here. So we're going to say, call it a function that does this dot set state with previous state and updates count to prestate.count plus 1. Little inline increment function. It looks awful. You shouldn't do it this way. But for the sake of time. Compiled successfully. Now does it work? Sweet. React still works. Now notice, is there any distribution folder yet? No, so I have not made Webpack do the build process. What I've had to do is run the Webpack dev server, which does a quick build. It does run through our babelrc file, our Webpack config file, but it doesn't actually output anything. It does like a live streaming of the final result. If I need the final result in its own directory for deployment, I need to run another command. What is the other command we added to our package.json file? npm run build. I'm going to say npm, let's see if npm build works. If it doesn't, we're going to say npm run build. So that's running our build process. This is where Webpack gets its work done. And now we have a distribution folder. We open the distribution, we see there is a index.html, a main.js. Main.js, here's all our JavaScript. Pretty straightforward, right? Now, do you know what this is referred to as when you see code that looks like this? Gibberish. Gibberish is a fair answer, but it's not the right one. It's a minified code. The computer doesn't see any difference between when we call a variable name and call a variable n. So it takes all of our variables, everything that we have, and makes it as small as it can, condenses it all together, because again, it doesn't care about white space either. You can see all sorts of interesting things happening here. And we could definitely write our code like this if we hated ourselves. So this is the entire React package, React DOM package, and our code all bundled and ready to go. It's so pretty. And look at that. I understand that portion. Create an element. This is our app. So it's creating our app element and render it here. So like here's our set state for our count incrementation. Call it increment. It's a button on click. This is what React looks like if it's not written in React. All right, so that's the main.js. Here's our index.js. What's different between the template we made and the template at output? Yeah, it just references the file it created. So we're back to a regular file that, interestingly enough, I've stopped my npm dev server. Let's just do this. Let's go to index.html and go live. Now my React app's running as if I made it with vanilla JavaScript and HTML. This is a live dev server, not the Webpack dev server. I'm running this index file like we did from the first week or two. So there's some of the magic behind the curtain. But wait, what if we were making a full stack app? Do we use Webpack on the back end? Trick question. You can, you don't have to. We aren't using Webpack on the back end so far in the course. How do we know that? What keyword do we use to import things on our back end? require a module.export, which is not the newer syntax, it's the node syntax. So we could use Webpack on the back end if we wanted to, let's say, use the import and export default features, but we really haven't needed it. So I'm going to keep my Webpack just for the front end, but I would like the ability to have a back end and have my server request proxied. So this is, again, where Webpack will just keep growing and growing as you need different configurations depending on what you're making. In my Webpack config, after plugins and module are just two of the properties you can give. There's another one for dev server. And we need to give it a proxy, just like we do with create React app. A little different though. We need to give it a context. When requests start with what do you want to use this proxy? Well, when a request starts with /, it doesn't start with HTTP. When it starts with this /, I'm requesting my own server, not a third party. So this is the context in which I want you to proxy. I could even put /API here and / as well. Give it multiple contexts. Any requests that start with this or start with this should go to our server. Of course, we've been doing this on the back end, which I think is a little easier to follow, but you can give it as many contexts as you need for this. And what's the target? Where do you want me to proxy this to? HTTP, localhost 7000 is what I usually use. And now we have our proxy set up just like Create React App has it. If we wanted to use env files, there's another thing for that where we have to configure our environment. And so that's where you're just like, how do I configure Webpack for .env files, Stack Overflow? And there's your answer. And then you click the link to actually learn what's happening eventually. But overall, it's not a whole lot of code, right? 51 lines, 4 lines in here. And then we just built our app on top of it. But knowing what's happening under the hood and the amount of things you have to install just to make this work is where the challenge really comes in. So I've been looking at these one by one just to know more and more about what they do. I would suggest the same for you once you've used this once or twice, but feel free to build apps with it. And if you're looking for the write-up on Slack, or not on Slack, sorry, the coursework site, it's Webpack, Bundling Front-End and Full-Stack React Applications, published in 2018. There's a couple of older dated ones I just need to remove. But this will go over, first it'll tell you every single plugin and dependency we installed. Show you how to set up your directory and then go over it piece by piece. And that's that. Any final thoughts or questions? I'm seeing some pained looks. It's cool though, right? This is doing something magic. Okay, we all use a little bit of magic in our code, but in reality, it's, you know, code. All right.